Hey everyone, today we're going to break down a simple but incredibly powerful technique from a new research paper that can make the LLMs you use every day way more reliable. So if you've ever battled an LLM hallucination, this one is definitely for you.
You know the drill, right? You ask an AI assistant to generate a chunk of code or solve some logic puzzle, it spits out an answer with total confidence. Everything looks plausible, the code is clean, but it's just plain wrong. And that creates bugs, it creates rework, and it ultimately kills our trust in these tools, and our clients feel that pain too.
And that's really the core conflict, isn't it? On one side, you've got us, developers and architects, trying to build robust, reliable software for our clients. And on the other, you have this brilliant, but sometimes arrogant, co-pilot that cares more about sounding good than being right. Well, today we're going to fix that.
Okay, so here's the game plan. First, we'll name the problem. Then we'll introduce the verification-first strategy. We'll see it in action, look at the hard data that proves it works, and wrap up with a practical playbook you can start using tomorrow.
So why do LLMs even do this? Well, it turns out this tendency has a name, and it's rooted in a cognitive bias that, we humans know all too well.
The paper calls it egocentrism. Just like a person who falls in love with their first idea and refuses to see its flaws, an LLM prioritizes its own, initially generated output. It's obsessed with keeping the sentence flowing and coherent, even if it has to completely bend logic and facts to do so. This is the root cause of so many of those confident hallucinations.
So, picture your LLM like this guy. It's generated its answer, it's proud of it, and its internal programming makes it extremely difficult to take a step back and critically review its own work. It's just too invested in its own perspective. But what if we could force it to take a different perspective right from the start?
And that brings us to the solution the researchers call verification first. And it's a beautifully simple, almost counterintuitive shift in how we structure our prompts.
This slide here is the perfect analogy. Think about a maze. Finding the path from the start to the finish can be really complex. But if I give you a potential endpoint and just ask, does this path work? Well, verifying that is often way easier. That's reverse reasoning. The paper argues that verifying a given answer is cognitively less demanding than generating a correct one from scratch. And this illustrates the change brilliantly. It's almost laughably simple. Instead of just asking the model to solve the problem, we give it a potential answer. It can even be a totally random, trivial guess. And we explicitly instruct it, first, be a critic, check this answer. Then, be the creator and give me the right one. This simple little trick forces the model out of its egocentric mindset.
Okay, let's move from theory to practice and see how this actually works. The paper gives some fantastic examples.
Let's start with this classic riddle. It's designed to trick our fast, intuitive thinking. The answer that immediately jumps into your head is probably 10 cents. And guess what? LLMs with standard prompts make the exact same mistake. Using a standard chain of thought prompt, the model follows its egocentric bias. It generates 10 cents and then builds a plausible-sounding, but logically flawed, explanation around it. It walks right into the trap, just like most of us do.
But look what happens with verification first. We give it a random guess, like €1. The model's first job is to check that. It quickly realizes, okay, if the ball is €1, the bat is €2, the total is €3, that's wrong. This active verification, this process of working backwards, forces it to set up the algebraic equations correctly. It activates its critical, logical side and gets to the right answer, 5 cents, effortlessly.
Now here's the crucial part. How do we use this for complex tasks, like writing code? Well, the paper proposes an iterative approach called ITER-VF. First, you generate a baseline draft of your code. Then, you feed that entire code block back as the candidate answer in a new prompt and ask the model to verify and correct it. The LLM essentially becomes a powerful code reviewer, helping you spot bugs and improve the quality of your code before it ever even gets to production.
Okay, this all sounds great, but does the data actually back it up? This is where it gets really exciting. This isn't just a neat trick, it's a measurably superior strategy.
Let's look at performance on a tough math benchmark. ITER-VF, the blue bar, hits 52% accuracy. That's a significant jump over other popular strategies like self-correction, where the model just reflects on its own answer, or self-consistency, where it kind of votes on several generated answers. ITER-VF is just flat out more effective.
But what's the cost? Is this going to blow up our token budget? This slide tells us, absolutely not. The overhead is minimal. For a massive leap in performance, we're seeing an increase in output tokens of about 20 to 50%. Compared to other scaling strategies that can multiply your costs, this is incredibly efficient. That's why the authors call it an almost free lunch.
Okay, this is all fantastic. But the most important question is, how do we, as developers and architects, actually integrate this into our workflow to deliver better results for our clients?
Here is your actionable playbook. For simple, one-off tasks like answering a factual question, just use the basic VF prompt with a trivial guess. For anything complex, generating a new feature, writing API calls, refactoring legacy code, use the two-step iter-VF process. Generate, then verify and correct. This should become your new default.
This quote from the paper's conclusion just sums it up perfectly. Let's break it down. Reduces logical errors and mitigates egocentric biases. For us, that means fewer bugs and more reliable code for our clients, without the need for additional training. That means you can use this today with the models you already know and use. And without expensive sampling, that means it's cost-effective. It's a pure prompting strategy that gives you better results for a tiny bit of extra effort.
So I'll just leave you with this thought. Think about the last tricky bug you had to chase down that came from a piece of generated code. How many of those hours, how much of that client frustration could have been avoided with a single extra sentence in your prompt?
And hey, if you want more deep dives into tech topics that can actually make a difference in your day-to-day work, explained in a way that just clicks, do your YouTube algorithm a favor and hit that subscribe button for VibeDoc. Because if you don't, it's just going to assume you only want to watch cat videos. And while cats are great, they probably aren't going to help you ship better code. Thanks for watching.